Hi, my name is Mike, and today we'll be talking about error handling in Go. So this talk at a high level is going to be the core patterns that we see in error handling in Go. And then later on, towards the end of the talk, we'll talk about the Upspin project and some lessons we can learn from there. So briefly, some common patterns. So we have package level error variables. These are also called Sentinel errors. And by the way, a lot of these things that you're going to see, they're a rehash of David Cheney's talk from 2016 GopherCon. But I thought I would just at a high level mention them here. So we got Sentinel errors. These are usually either exported or unexported package level variables. And we can either check for them in our code and check for their existence. So we can do if error equals and do a comparison and check for that value. And then we can handle the error. An interesting use case for this is checking for the error, and then you can either pass it off as an error, or you can actually signify that an error has not occurred. And this actually happens in the standard library in the filepath.walk function, which is really interesting because you're checking for a directory and you're saying, no error has happened, but I just want you to skip over this directory when you're recursively going down the tree. Kind of a tip, try to avoid doing comparisons on the return string. So you can do error.error, get the string and compare it. You typically want to avoid this. It might be okay in tests, but you typically want to avoid that kind of pattern because your code becomes brittle and it's just not a good pattern. Next, we have opaque errors. These are the simplest kinds of errors. You check that an error has occurred. If it has occurred, pass it up to the caller, which might pass it up to its caller, and it might pass it up to its caller. And then eventually it either gets printed out or logged somewhere. And that's usually cool if you're using the standard library. The Go maintainers are pretty good at giving you good errors. But if you're importing a package from a third-party vendor, and they return something like errors.new somewhere in their program, you are in for a very, very long debugging session. So next we have error types. These are used quite commonly. So pretty much any type in Go can implement the error interface. It's a single method interface. So any type that can describe itself as a string can implement the error interface. So a lot of times you'll see structs with the error method. So they would call error and then return a string, and that would allow them to implement that interface. And these are useful because it allows the caller to do a type assertion and check that that type has occurred. And then if the caller wants to add more context to their error handling or log it out, they can access fields so long as they're exported. And then you can also keep some fields within that struct unexported, so you construct the error how you want to. And another really cool thing you can do with error types is that you can create error interfaces. So you're not only checking for the underlying type, but you're also checking for the behavior of that type. And this becomes a really useful property because let's say you are talking to some server across the network, and that server returns a 503 and says, hey, I'm too busy right now, but retry in, let's say, 5 seconds. So you can assert for that error in your code. You can then call a method to check, is this a temporary error? And then retry within your code. So this pattern becomes quite interesting. And it allows your code to have, to assert for behavior instead of just a type. Next, we have formatted errors. So in the very early days of Go, you would typically see a lot of Go code using fump.errf, and that is because you are not trusting somebody else's package to have enough context, or you just want to add your own context to signify an error has occurred at some location, and we are going to signify to wherever that error is handled what happened. And you can decorate the error. So for example, let's say you are dialing some place, you have an address, you have a port. So what you do is dial, you throw in a formatted verb, you give the address that you dialed, and you throw in the original error. This is okay, but there are better ways, and we'll talk about them in a sec. But the big problem with this func.errorf is that you're losing two things. If you originally had a type, you are taking the caller's ability away by checking that error. So you're taking the type assertion away. So here's a contrived example. We have an error that's a DNS error. We're then throwing it into func.errorf. We're mixing that in with a string, and we're returning it back to the caller. And does anybody know what the returned error type will be? Just shout it out. Error. Cool. All right. So it's going to be errors.errorString. This is the default Go standard library error type. So we started off with a DNS error, and we got this error type. So no longer can we do any type assertions. And also, we are losing the context. If that error was a Sentinel error and it had some specific string, we're losing that as well. So there are better ways to handle errors. And in my opinion, that's wrapped errors. And I'm not going to be surprised if one day this makes it into the standard library. Just out of curiosity, how many people here use the package library errors from David Cheney? All right, so the folks watching this, if this ever gets recorded, every single person raise their hand. I really recommend everybody use this, because not only do we get the advantages of being able to annotate the error, so in other words, add context to whatever error that we got, but we're also giving the caller the ability to inspect that error. So the package is very simple. I think there's only like 5 or 6 functions, and it has a very high level, high integrity. So what we do is we call errors.wrapf. We throw in the error that we got. So we do our normal error checking if error does not equal nil. If it's not nil, we throw in the error into errors.wrapf. We then annotate that error, and there are formatting verbs available. So if we want to add some more context, maybe it's specific to a user that we looked up or a directory that we looked up, it's there. Probably the error will have the context of the directory, but if we're using somebody else's package, we have no assurance of that. But in addition to that, this package comes with a function called errors.cause. So you can throw in, so let's say you return to the caller errors.wrap, and that caller has the ability to inspect the error. They can do errors.cause. They can get the underlying error. So the way the cause works is it looks recursively for the very first error that you got. And then you can do a type assertion on it. So in this case, we're checking, is this error of type net.error? And if it is, then we're going to call a method to assert for its behavior. So if we go back to that original example, we're talking to a server who said, hey, I'm too busy right now, come back. This helps in those situations. So that's kind of error handling as we know it today. There are other ways of doing error handling, but I don't think it's worth mentioning them because you're just fighting Go, and we don't really want to fight Go. It has its idioms, and we should probably stick to those idioms. But there are other lessons that we can learn from packages that handle errors in an interesting manner. Oh, I forgot to start. Moving on. So coming back to the original question, how many people have heard of Upspin? Upspin is a project where you can, as a user, try to get any file across the network. I'm not going to go into the details of how it works. The only things that are worth mentioning is that it's a distributed system. You have a client, and that client reaches across the network and talks to a server, which is going to talk to another server and maybe another server and maybe another server. And then eventually that one server is going to look up some cloud provider and try to get a file or resource from that cloud storage provider. So the motivation behind the Upspin project, specifically its errors package, was that it would allow programmers to build informative errors, something that's easy for both users of the program to understand, and also enough context for the implementers when it comes to debugging. So the errors package in this project is one of a kind. I do not advocate that you go out and use it because you can't. It's specific to this project. However, there are some interesting lessons that I think we can learn from this project in the context of error handling. It has a very small footprint. Last time I checked, I believe it's about 500 lines of code. And maybe a third of that is comments. So it's well documented. It has a small footprint. And you only ever use errors when you're dealing with errors within Upspin. So you don't import the standard library errors package. You don't import fump.errf to try to build it. You don't import David Cheney's package. And just to digress, I think David Cheney's package is good when you're dealing with packages that you have no idea what they're returning. And this project is more of a binary that's meant to be used by clients. So the people that are dealing with errors are typically going to be the implementers. So why don't we just talk about the errors package. So at the heart of this package, we have a custom error type. And that custom error type is a struct. And that struct has 5 fields. So it's very, very small. It obviously implements the error interface, so we can pass it around as an error to go. And seems like this is a very, very popular emojis when it comes to talks. Does anybody notice anything interesting about the fields in the struct? Just shout it out, even if it's.
Can you zoom in on the struct?
Yeah, for sure. Let's zoom in on a struct.
Yeah, there we go.
More? Do we have to keep zooming until someone says something? More?
Enhance.
Man. Okay, okay. Error is one of its properties, yes. But.
Does that have a shape of the?
Pardon?
Does that have a shape of an internal representation of an interface?
No, I'll just tell you. Every single field has a unique type. Okay? Every single field here has a unique type. So although we have 3 fields that have an underlying string representation, they're actually a unique type. And having an error like this with a very, very narrow scope makes for a very interesting property. You can build one function that will accept a variadic number of arguments as an interface. And then within that function, we're going to do a type assertion into the arguments that you passed in. So we have a simple type switch. So we range over the arguments. We check for the type. If that type matches one of these types, we're going to assign it to that field. And there are some rules about how the error is constructed. For example, actually, we're going to talk about that in a second. Yeah, so we loop over the arguments to build an upspin error based on the type. So that property makes it really, really easy for programmers to build their errors. And I'm sure that if something is easy for a programmer, they're more likely to use it. You have one function, and you throw in some types in there, and it takes care of the rest. It's obviously not that easy, but it's a contrived example to prove a point. So for example, let's say we are doing some work in a server that has a lookup method. It takes an upspin path name, so just a path to where that item exists in the upspin world. And then usually by convention, at the very top of the method or server function, you define which package and which method or function that error happened, like where it happened. So for example, here, this package came from dir server, and we are doing the lookup method. So then throughout your method, anytime you construct an error, you throw in OP, so OP for operation. That is by convention the first thing that they add. And later on, we'll see that that operation gets printed out nicely to the screen. Because remember, the Upspin project is a distributed system. So along the way, when these errors happen, they get marshaled and unmarshaled. So it's not just an opaque error where you're simply checking if an error happened, communicating to a server, and then you respond back. We're actually seeing an executional trace throughout the system. So path name would be the, let's say, the file path. Errors dot not exist. That's a kind, and we'll see how that works in a sec. And error is the underlying error that was returned from whatever work that we're doing. So let's say we're walking some directory, and then it returned an error. We throw the error into this errors.e function. There are some special rules. So let's say, for example, you get an error and you can't classify it. You can simply say where it happened, and you can say unexpected error. And that literal string gets promoted to an error type, and that is what gets assigned to here. And then once a client gets that error back, so it gets printed out, this is what they would see. They wouldn't see a huge, giant, long stack trace, which is actually not really useful for either users or implementers. But here you would see an executional error built up from the ground up. And the string method, so the error that you can call, the error method that you can call in the upspin error, will format it neatly. And I think it's worth showing this. So you can see here that there are some rules about how things are padded and how things are displayed. And the beautiful thing is that as an implementer that's simply writing some code, this has already been abstracted. You don't have to think about how to build up that error. So all you have to do is think about errors.e, what makes sense in the context of this error. Let's throw it in there, and then eventually we'll see some sort of output like this. And another really interesting thing is that certain errors that happen, let's say, at the first level, they get bubbled up to the very top. So the idea is that when this error gets presented to the client, within the first line, they should be able to determine what the problem was, and there should be enough context for them. So just out of curiosity, would you agree that there's enough information for you to determine what happened here? Perfect, awesome, great. Everybody said yes, that's great. So you can see that there's some nesting going on with the lines below, and they're indented. So that becomes really useful. Oh, and another useful thing is that redundant fields are suppressed. So if you do errors.fap or func.error or the other error handling strategies, you often typically do a few functions where you pass in, let's say, the path name, but at each time you say like that path failed or that path failed, and then when it gets bubbled up to the caller or whoever's handling that error, they're going to see it printed out 2, 3, maybe 4 times. It happens sometimes, I've seen it, but with this way, the most critical errors get bubbled to the top and they're not duplicated. So then I guess the idea here is that errors are for users, not just for programmers. And this is especially true if you're writing software. That's not necessarily a package or a library, but it's kind of, let's say, a CLI tool that's consumed by others. And then other interesting things arose from having a struct with type is that you can provide a very simple function called is. And then you can pass in a kind, and you can ask, is this error of this kind? Which gives us almost similar behavior to the type assertions that we got from asserting for behavior. So for example, you can ask, is this an errors.io error? Or is this an isdir kind? And we can see that right here. So there's not that many of them. There are some, and the idea is that when the kind gets bubbled up to the very top, one of these will get printed out so that it becomes clear what kind of error it is, which will give the client some information. But in addition to that, it also makes it easy to change the execution path of your code by inspecting the error and asking whether it's of that kind. Yeah. I don't think I'm going to go into this. I think we've had enough errors. So a majority of this talk was based on the phenomenal talk that David Cheney gave. I think it was 2016 GopherCon, where he talked about errors, and he went into way more detail than I did about the 4 or 5 different ways of doing patterns in error handling. So I highly recommend checking out this video. It's a phenomenal talk, highly recommended. And also the latter part of the talk was an inspiration from an article Rob Pike posted, I believe in December of 2017, where he kind of gave a rundown of how error handling works in Upspin, and I thought it was an interesting enough topic to talk about in this meetup. So with that, thank you for your attention, and if there's any questions, let me know. How's that for time? Oh.
Sorry. Thanks for that. That's great. I'm just I had a thought in terms of like say the Dave Cheney approach, where you mentioned we're going to inspect this thing recursively to determine. And I had a thought that I thought was kind of interesting is like if there's like static analysis to like get a kind of idea of like how deep are you like bubbling up errors in your code base might be an interesting thing. But secondly, that to me means it's like a linear search through the structure, whereas the Upspin approach, when you have the is, it seems like by the time you receive the error, there is only one kind of. Am I seeing that correctly? Like,
yeah, that's correct.
So it would be like an ON type of, or O1 type of search on that?
I believe both approaches take the stance that you should only ever handle an error once. And because you're only ever handling the error once, it should only be of one kind. So yeah, it goes recursively. And I believe in David Cheney's package, there's actually a stack trace. So if you implement an interface, you can access the entire stack trace. And then inspect it for yourself, and you can decide how much of the stack gets printed out, like let's say the first line or the entire thing, and so forth. But with Upspin, there's promotion that gets lifted up, so it kind of does go recursively linearly, but it does bubble up the critical fields, and I believe those are path, name, and kind.
Cool. Thank you.
Sure.
So, I just want to understand, can you compare this to your underlying error types?
Error types?
Yeah, so it's saying bubble top, right?
Yes.
So you know if this error is based on a certain error.
Yes, you can. So I guess I didn't explain this well, but that's a very good question. So when you see this get printed out, the very first error that we got was from the remote package, which talks to a cloud provider. And what essentially it means is it tried to do a get fetch operation and look up some path to I don't know, file. And then it gives you back a 404 indicating that it was not there. And then as that error gets returned to all the callers within that distributed system, you can then trace back. So it started off in store remote, then directory server did a lookup, then the remote server did a lookup, and eventually the client did a lookup, and that would allow you to debug that. Sorry, I don't think I quite understand.
All right, so at the end of the checking for this error,
Yes.
can you compare with whatever the remote capability is being there, right?
Yeah. Yes, you can. You can ask, is this error of errors not exist? And it will give you true.
That's why they have the kind property.
Yes.
Reflecting.
Yes. Yeah.
And again, so I guess the takeaway from this is like be smart about your errors. Maybe use the package implementation, but also there's ways to build your own annotation system that's similar to Salesforce.
Yeah. One of the first things that they say is this is a one-of-a-kind package. You can't use it, but go out and experiment. And if you have a small footprint with how you can describe all your errors, it doesn't hurt to try and experiment. Like maybe this won't work for anybody except for Upspin. But it's just interesting concept, I thought, in the whole discussion of error handling in Go. Because a lot of times I feel frustrated. All the time we get, if error does not equal nil, oh, it's too many times, blah, 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 blah. And then people get frustrated because they see if error does not equal nil in their code, and that's what people talk about. But I feel like we can move away from that.
I'm curious. So, are there any fails? I'm not sure if you mentioned this earlier, but are there any fail safes? Like, if this system failed processing an error, like, will you see the errors kind of like wrapping, or is there anything to make sure that if something goes wrong here, you're still going to get something?
Yes. Yep.
Okay.
At all times, something will get printed out to you.
Okay.
But they have been quite diligent. I've been using Upspin since kind of the first day it was introduced last year. And as a client, I was always able to debug by getting enough context. So I was kind of like a client and an implementer at the same time.
If you're trying to return an error to a client, like a web app or something, is there a convention for taking like an Upspin error and saying like, oh, this kind of field is all right after a client, where these details aren't? Or
No, I wouldn't use this approach for servers that return errors to clients.
right, so you just check if that's fair enough.
Yeah. I wouldn't use this approach for that. Yes.
Yeah, back to your takeaway point. I think like data changes of package errors is great for like simple packages. So you can sort of trace back the error where it happened. However, if you have a large monolith model like Upspin, it's great to have your own error. And those maybe even on top of data chains.